Okay, here's warm-up 5.8. We've got a two-column proof. The statement's already filled out, but we're going to fill out the reasons or justifications. Okay, so first, looking at the given info, it says that PQ bisects angle SPT. So let's make sure we understand what that means. So PQ is right here, and it bisects SPT. So SPT, that's this angle down here at this corner. So if that segment bisects that corner, that means it's going to cut it into congruent angles, okay? So this is going to happen. That's what bisect means, okay? So our first reason is this is just the given info, and I kind of got ahead of myself there, but now I can say that these two angles are congruent by the definition of bisect, right? Since it says, it doesn't say that those two angles are congruent in the given information, but it does say that PQ bisects the bigger angle, and by definition of bisect then, we can say that those two angles are congruent. Okay. Also, we've got some other given information that I want to put in the picture. It says PS is congruent to PT, so let's put that in there. Okay. And then I want to start kind of thinking through this. I processed the given information, but now I got to see what I can do with this. So we're trying to prove that this angle, angle S, and angle T are congruent to each other. So in order to do that, we're going to need to get the triangles congruent first. Once we have the triangles congruent, those will be congruent parts of those congruent triangles. Okay, so next up it says PQ is congruent to itself. Well, anything is congruent to itself by the reflexive property of congruence. So I put those two little ticks there, but this is going to be reflexive property of congruence, and I just like to put a little congruent symbol after that, that represents reflexive property of congruence. Okay. Now looking at the triangles, next step says the two triangles are congruent. They're going to be congruent by SAS. I've got two sets of sides on each of these, and those are the included angles. So that angle is in between those two sides. Those two marked sides form that angle. So that means that A would go in between the S's in the side angle side triangle congruency theorem, and I'm just going to write that like that. Okay. Now that the two triangles are congruent, these would be corresponding parts of those two congruent triangles, and corresponding parts of congruent triangles are congruent, and that's what CPCTC stands for. Once you have congruent triangles, you can say any of the corresponding parts are going to be congruent by CPCTC. Corresponding parts, congruent triangles are congruent. Okay, and problem number 2, which of the following theorems are used to prove triangles congruent? Well, hey, we just used SAS. So this one is, I'm just going to circle the ones that work, and I'll cross out the ones that don't work. Side, side, side is another one that works. Angle, angle, side works. This would be two angles in a non-included side. Okay, this one spells ass. It doesn't work. You can remember it easily like that because they wouldn't put that in the textbooks, right? AAA actually doesn't work. People try to use this all the time, but let's think about a little equilateral triangle and a big one. Well, they wouldn't be congruent, right? All the angles might be 60 degrees in both of those triangles, but they're not the same size, so they're not congruent. HL does work. This is the only time that ASS works, but it's with a right triangle, and we call it HL. Okay? And these last two theorems are theorems, perfectly good theorems that work, but they're just not for proving triangles congruent. The base angles theorem says that if you've got an isosceles triangle, if you've got two congruent sides, then you're also going to have two congruent angles. And that's true, but it's not to prove triangles congruent. So that one is not on the list either. And CPCTC, we just use that over here. We use that to show that these angles are congruent, not that triangles are congruent. Use that to show corresponding parts of congruent triangles are congruent, not that the triangles themselves are congruent. So that one's not in the list either. Okay, that's the end of the warm-up, and I'll see you next time.